Hello and welcome to this R tutorial. So in the previous tutorial we did the data preprocessing step. We first imported the dataset the usual way with the read.csv function, but then we explained that we needed to create a sparse matrix containing all the transactions that occurred in the store during the whole week, and to build this sparse matrix we used the read.transactions function, including the rmDuplicates argument to remove all the duplicates. And this sparse matrix is exactly what we need to train our Apriori model on the dataset. And that's what we're going to do in this tutorial. We're going to make the rules, if I can say that. Okay, so now thanks to the A-rules package, the training is going to be very simple because we're just going to use one function, which is by the way called the Apriori function, with only two arguments. So let's do it. We're going to create a new variable and we will call it rules because this variable will contain in some way the different rules of our business problem. So rules here and then equals, and that's where we use the Apriori function with the different arguments. And so we're going to input two arguments. The first argument is going to be our dataset, and the second argument is going to be the parameter argument that will contain the choice of a minimum support and a choice of a confidence support. So let's have a look at these arguments. I'm going to press F1 here. And here I have some info about the Apriori function. So as you can see, the first argument is data. So let's input it now. That's the easiest argument to input. So data equals dataset, and then comma, and then the second argument. So the second argument is parameter. And as it's written here, the parameter is an object of class Apparameter. And so this object will contain the minimum support that we will set ourselves and a minimum confidence. And we can also specify a maximum of items you want to have in the rules. So that's given with maxlen. And actually, it's also possible to include a minlen, specifying the minimum number of products you want to have in your rules. But we won't actually need that. And what we will need inevitably is the support and the confidence. So let's input that. So parameter here. And we need to include the support and the confidence in this parameter the following way. We're going to take the list function. And in this list, we're going to input the support and the confidence. So I'm going to add the two arguments here, and then we'll see what value we will input for these two arguments. All right, so let's take the slide of the intuition tutorial about the Apriori algorithm, and let's see what the different steps of this algorithm are. So the first step, as you can see, is to set a minimum support and confidence. So that's exactly what we're about to do right now. We are in the first step of the Apriori algorithm, and that consists of choosing a support and a confidence. So the choice of a support and confidence is not a general rule. We cannot express the support or the confidence with an explicit equation. It actually depends on the business problem itself. It actually depends on your goals, the goal related to your business problem. It also depends on your data set, the number of observations you have, the number of items. So that depends on different circumstances that don't allow us to make some general rule about how to calculate the support and the confidence. But don't worry, it will make a lot of sense when we explain how we calculate the support and the confidence here, and you will be able to apply it to your business problem. Okay, so let's start with the support. The support of a set of items I is equal to the number of transactions containing this set of items I divided by the total number of transactions. And this support argument that we're inputting here is actually the minimum support you want to have in your rules. That means that the items that are going to appear in your rules will have a higher support than this minimum support here. And same for the confidence. So what we must ask ourselves is that what supports do we want to have of our different items in the rules so that the rules are relevant? Because, for example, if we go back to the plot here with actually the 100 observations, which is this one, if we zoom on it, well, we can see that we have a lot of products that are not purchased very frequently. And these specific products are the products with small support, because a few transactions contain these products here. So when you divide the number of transactions containing these products by the total number of transactions, then you'll get a small support. And since these products are not purchased very often, they're not very relevant for our optimization problem because, we want to optimize the sales, but what we want to optimize overall is the revenue. And since the revenue is a linear combination of the different numbers of products, where the coefficients are actually the prices of these products, Well, in order to optimize the revenue, we would need to optimize the sales of these products here that are purchased very often, rather than these products here that are less purchased. And so what we need to choose here is a support that will only include the products on the left of this vertical bar here that will correspond to the minimum support. So for example, let's say the value here on the y-axis is 0.005, then that means that all the products on the left of this vertical bar will have a support higher than 0.005. And so if we set a minimum support of 0.005, then the rule will only contain the different products of this left side of the vertical bar here. And so now how to choose this support? Well, we need to look at the products that are purchased rather frequently, like at least 3 or 4 times a day. Again, that depends on your business goal, but what's for sure is that if we manage to find some strong rules about items that are bought at least 3 or 4 times a day, then by associating them and placing them together, customers will be more likely to put them in their basket, and therefore more of these products will be purchased, and therefore the sales will increase. So that will be the starting point of how we're going to set the minimum support. We're going to consider the product that are purchased at least 3 or 4 times a day. And then we will look at the rules. And of course, if we're not convinced by the rules, we will change this value of the support. That's how we work with the Apriori model. We try different values of the support, different values of the confidence until we are satisfied with the rules and until we think it makes sense. And we can also try these rules within a certain period of time. And then we look at the impact on the revenue. And if we don't observe a meaningful increase in the sales revenue, we can later change the support and the confidence to change the rules and then experience again until we find the strongest rules that optimize the sales. So that's actually what happened in real life. But of course, in these tutorials, we're going to try with products purchased 3 or 4 times a day. And so we'll see what happens. Okay, so actually, we didn't set the support yet. We just decided that we will look at the products that are purchased at least 3 or 4 times a day. But that will quickly lead us to the support, because if a product is bought, let's say 3 times a day, that means it's purchased 3 times 7 equals 21 times a week. And since the support is the number of transactions containing this product over the total number of transactions, and since there are 7,500 transactions, then we get the minimum support that is equal to 7 times 3 over 7,500. So let me re-explain that by writing this here. So, okay, we said we considered the products that are purchased 3 times a day. So that's 3 here. Then since the total number of transactions were registered over a week, that means that if we consider the products that are purchased 3 times a day, that means they're purchased on average 3 times 7 times a week. So this 3 times 7 equals 21 here is the number of transactions containing this product bought 3 times a day over the whole week. And now we need to divide by the total number of transactions to get this minimum support. And the total number of transactions is actually 7,500. And this value here that we're about to compute is nothing else than the support of a product that is purchased 3 times a day. And we want our rules to consider only the products that are at least purchased 3 times a day. So all the products of our rules will have a higher support than this support here that we're about to compute. So let's compute it, let's find out what it is, and that's the value we'll give to this support parameter here. So right now I just need to press enter, and that's the value, 0.0028. We will round this to 0.003, and so that is the minimum support of the product that will be considered by our rules. So let's input it, 0.003, right. Okay, so that's it for the support. Now, the second sub-step of our step 1 is to set a minimum confidence. So the choice of the confidence still depends on the business problem, but mostly on your business goals. So what we'll do now is we're not going to compute a confidence like we computed the support. We're going to start with the default value and then decrease the confidence step by step until we get some relevant rules. Because, the confidence is kind of an arbitrary choice. We don't want to have a too high confidence, because if we get a too high confidence, we will get to obvious rules, rules that we don't need a machine learning algorithm to understand where we need to place the products next to each other. And we shouldn't have a too small confidence, because if we get a too small confidence, we will get some nonsense rules like, if I'm buying chocolate, I want to buy shampoo. That's a nonsense rule that doesn't make any sense. And that's the kind of rule we'll get if we set it to small confidence. So we will start with the default value, which is actually 0.8, I think. We will have a look at it. We can go back to help here to look at the description. And if we want to have the info about these two arguments here, support and confidence, what we need to do is click on this AP parameter here, which is the class. And here we go. That gives you the information of the parameter argument of Apriori and Eclat. Eclat is the other model that we'll make after this section. And as you can see, we get the informations about the support and confidence and other arguments. So these are actually the arguments that are both in Apriori and Eclat. And below, you have some additional arguments that are only for Apriori, because you'll see that the Eclat algorithm doesn't have a confidence in its algorithm and only consider the support. We will see that afterwards, but right now what we're interested in is actually the confidence, and you can see that the default value is 0.8, so that's what we will start with. I'm not saying we will get some interesting results. You can already imagine what we're going to get, because 0.8 is a very high confidence. Try to guess what we'll get with this high confidence 0.8, and don't worry, we will divide it by 2 to try some smaller confidences until we get some relevant rules. Okay, so that's actually ready. With this single line of code containing only these two parameters, the dataset and this parameter here with the minimum support and the minimum confidence, we train our Apriori model on our dataset. So let's select this line and execute, and here we go. Our Apriori model is created, and by the way, the rules are also created. So let's have a look at the info here. All right, so that's the Apriori model. And here we have the default parameters of this parameter argument here. So we can see that we have the minimum confidence here, 0.8, and the minimum support, 0.03. And we also have the min-len of the basket. That means that the basket that the rules will consider will contain at least one product. Well, we could have actually set 2 here to have at least 2 products in the rule. We'll see if we get a problem with that, but so far, the most important arguments we need to input are the support and the confidence. Okay, so the algorithmic control, that's not very important for us now. That's kind of a little more advanced. And here we get some other interesting informations. The most important information we need to look at here is the number of rules. We can actually see 0 rules here. That means that when we trained our Apriori model here, this model actually found 0 rule. And can you guess why? Well, of course, it's due to the choice of our minimum confidence. Because by setting this minimum confidence of 0.8, that means that all the rules made by our a priori algorithm have a confidence higher than 0.8. And what does that mean? That means that each rule should be correct at least on 80% of the transactions. So 80% is a lot. That means that the rule must be true at least 4 times out of 5. And that's why the a priori found 0 rule with a minimum confidence of 0.8, because no rule is true at least 4 transactions out of 5. So that's what I was telling you. We can start with the default value, but since we have a lot of transactions and a lot of products that the customers can purchase, well, of course, we need to set smaller confidence. So we will divide it by 2. So we will try now 0.4, and now let's see what we get. So let's re-execute this line. It will retrain the a priori model on our dataset and recreate some new rules. Here we go. Now we have 281 rules, much better. So that's a relief. And now, of course, what we're going to do is look at the rules themselves. We're going to visually see what the rules are. So we're going to see exactly which products should be placed next to each other. And we will see the strongest association rules. We will see what product customers purchase if they buy another product. So we will see all this very explicitly. And that's what we're going to do in the next tutorial. So I look forward to discovering these rules with you. And until then, enjoy machine learning.